Now, wouldn't it be nice if we didn't have to do the definition with this? Because the square root ones, think back to the homework that you just finished with. Doing those by the definition, you've got to multiply by the conjugate and clean stuff up, and then we put them in the denominator, and oh, it gets ugly. So what could we do here?
X to the 1/2.
This is the same as 2 times x to the 1/2 power, right? So now we can use our power rule, which says that y prime is, that 2 is going to stay there. Move the 1/2 down. X to what power? Negative 1/2. We've got to subtract 1 from it. 1/2 minus 1.
Oh, you subtract 1. You don't
Yes.
take off.
No, you subtract 1 from it. Yep. Well, how can I simplify that? Because that answer's not in the multiple guess there. How can I simplify that?
1 over root x.
1 over the square root of x. Now, how did he get there? Because that's definitely where we should wind up at. Well, this 2 and that 2 will cancel, just leaving me with x to the negative 1/2. And what can I do with x to the negative 1/2? If I make it a fraction, 1 over, then that becomes a positive 1 over x to the 1/2, which becomes 1 over root x. So you've got to be sure that as you're looking at it, you're thinking multiple guess. You've got to be able to get all the way out to this solution here, because that's the answer that would be there on the test if we gave you a problem that easy.
Wait, what?
Yeah, if we gave you a problem that easy. All right? Which there's always one like that. That looks ugly.
3.
Ooh.
1 over 3 cube root. Because x squared. Don't they don't
Mhm.
that look. I don't like that look.
It's so. Colin, tell me, what do you think?
It would be x to the 2/5.
All right.
3 times.
All right. So you're saying this, I think, is what you're saying, right?
Yes.
All right. So 1 over 3x to the 2/5. Can we just use our power rule right there?
Yeah. No? Yeah.
It's 1 over 3 times x negative.
All right. Can we use our power rule at this step here, or do we have to come all the way out here?
Yes,
Well, if we can, why didn't we do it over here? Somebody said we cannot. Why can't we then?
The denominator.
It's in the denominator. Our power rule only works if we've got the variable in the numerator. If the variable's in the denominator, we can't use that. That's something else that we're going to come up with in a couple of days. All right? So we have to move this x to the 2/5 to the numerator. If we move a part of a fraction to the numerator, the sign of the exponent changes. So what does my derivative become here then? Y prime becomes, I'm going to have the 1/3. To get my derivative, I take my exponent here down, negative 2/5 times x, subtract 1 from negative 2/5. Negative 2/5 minus 1 is negative 7/5. Negative 2 minus 5, negative 7/5. That is ugly. So that becomes negative 2/15 x to the negative 7/5. But that answer is not in our multiple guess there. So what else do we need to do? So that becomes negative 2 over 15 x to the 7/5. But that answer is not in our multiple guess.
Well, you have to 5 goes to the 7 1 times
Well, it'd just be like saying the root of.
2/5.
Okay?
Wouldn't it just be like saying the root of x to the 7th? Like the 5th root of x to the 7th?
The 5th root of x to the 7th is a way we could write it, but that answer is not in our multiple guess. Colin, you were on the right track, though.
Okay, well, 5 goes into 7
This 5 goes into this 7,
1 time.
so I can bring in 1x outside of the house. And what did I have left over?
2x to the 2/5.
and I have the 2 left over. This is the answer you'd see in your multiple guess. Negative 2 over 15x to the x, negative 2 over 15x, the 5th root of x squared. Okay? Can you see how to get there? Because now we've made finding the derivative easy. But getting it down to this fact here is a little bit more challenging, okay? Are we okay with that?
How do you know when to stop?
Good question. How do you know when to stop? On the test, when you get an answer that's in front of you. Okay. Here, best thing is no, you don't want any negative exponents, and you're not going to ever have a larger exponent inside than outside the radical. You're always going to simplify it down. If this were 5, 6, you could bring another x outside here. So that's a simple thing to do there. Okay? But it's very challenging to know that, to be perfectly honest with you. Okay? Well, let's keep looking at a few more problems. What's the derivative?
Zero.
I hear 0. I hear negative 6.
Well, no, negative 6x to the 0. We can just do 1, so you can just do like negative 6.
It's not a power.
No, but it's x to
3,
the
so
first
wouldn't it just be negative 2?
So it'd be
Okay.
It's negative 3.
Well, it just wrote 0.
0. Okay.
Zero.
Why 0? I want negative
I originally thought 0 and I'm sticking with
All
my
right. I hear a lot of zeros. Anybody? I hear 1. I hear zeros and I hear 1s.
negative 2.
I hear negative 2.
It's
We're really involved in this, aren't we? All right, well, let me rewrite this and see if any of you want to change your answers. That's the same thing. Now, do you want to change your answers any?
don't think so.
7 over 3.
Negative 7 over 3. Now, that's one I haven't heard before. So we had 0. We've got negative 7 over 3. I heard a 1. Where do we think?
Wait,
Had the dark horse candidate as negative
Samuel,
2.
be quiet. That's not the answer.
Power rule. Your power rule. Okay? This is x to the first power, right?
Yeah.
So what do we need to do? We bring the 1 down, right? So we've got negative 7/3 times 1, x to the 0 power.
It's 1.
Yep, so our derivative needs to be simply negative 7 over 3. Okay? We all right with that? You've got to be able to use your power rule there. Is that straightforward enough? Okay, let's look at a few more.